Hello, students. My name is Shesi George, your professional accounting teacher. Before you continue with this video, please try to subscribe to my YouTube channel. Thank you. So let's get started. In this video, we are looking at the application of calculus in business with the assumption that you have a prior knowledge about calculus. And what is calculus? It measures the rate of change in a particular function and is divided into two aspects. Number one, we have differential calculus, differential calculus, differentiation, and number two, we have integral calculus. That's integration. Okay. So that is calculus. Differential calculus, supposing you have a function of y equals to ax raised to power n, then it is represented by dy dx. So the differentiation of this function in respect to x will be, you reduce this to be n, the power multiplied by the coefficient of x raised to power n minus 1. All right, that's the general formula for differentiation. Then for integration, supposing you have y a raised to power n, this is integral. The integral of this becomes a all over n plus 1 raised to x n plus 1. All right, that is the integration. That's the general formula for integration. Students should take note of that. Okay, supposing you have, let's say for example, you have our y equals to x squared plus 2x plus 3. Okay, our dy dx, okay, will be 2x. Okay, you multiply by the coefficient 2x raised to power 2 minus 1 plus 2x raised to power 1 minus 1. Then the differentiation of a constant set to be 0. Okay, so at the end of the day, we have 2x plus 2. Okay. Now, supposing you are to differentiate y equals to x all over 2, x raised to power 2 plus 5x, you have to differentiate, integrate this. What do you have? You have the integral of, that is x all over 2 plus 1 raised to power 2 plus 1. All right, by following the general formula, plus 5 all over 2, that is x 1 plus 1. So at the end of the day, what do you have? X all over 3 raised to power 3 plus 5 over 2 x raised to power 2. So take note of that. Now, in business, when you have your total cost, let's say we are given the function of total cost, and the total cost, say, is 400 plus 5x. 400 plus 5x. Then you are asked to find marginal cost. So given the total cost function, this is a total cost function, and you have to find the marginal cost. So to do that, we need to differentiate the marginal cost function. I'll repeat, if you are given the cost function, these are cost function, all right, then you are asked to find the marginal cost. How do you apply the calculus? You apply the calculus by saying marginal cost is the total cost dx, okay, which is differentiation of a constant is 0 plus what do we have? 5 into bracket x raised to power 1 minus 1. Then that 1 will have multiplied this 5. Then what do you have? Marginal cost will be equals to 5. Okay? Alright, so if you are giving total cost function, if you want to find the marginal cost, what do, class? You differentiate. Take note of that. But if you are giving, on the other hand, if you are giving marginal cost function, say the marginal cost function is 4x raised to power 3 plus 2x raised to power 2. This is a marginal cost function. Okay? Then to convert back to total cost, to find the total cost, you need to integrate this function. You need to apply the integration function. So which is what? We have open brackets. You add 1 to this and divide by, so it will be 4 all over 4 x raised to power 3 plus 1. So 3 plus 1 is 4. Okay? Plus, you add 1 to this. You now say 2 all over 3 x raised to power 3. That is 2 plus 1. Alright? So at the end of the day, our total cost function will be x raised to power 4 plus 2 all over 3 x raised to power 3. Okay? So the general formula is that, how do you apply the calculus? If you are given the marginal cost function, if you want to find the total costs, what do? You will integrate the marginal cost function. You integrate. Okay? So students should take note of that. If you are also given the revenue function, and that revenue function, say we have 4t plus 7x, 40 plus 7x raised to power 2. Alright, if you are given something like this, 40 plus 7, the revenue function, and you are asked to find the marginal revenue. So what do? To do that, you also differentiate the revenue function. You differentiate the revenue function. You find the rate of change, the revenue function, to get the marginal revenue. So to get the marginal revenue, you will differentiate the R, the X of a constant is 0. The differentiation of a constant is what? 0. Then plus, what do we have here? So we have 2 multiplied by 7x raised to power 2 minus 1. Okay? So our marginal revenue, therefore, will be equals to 14x, because 2 minus 1 is 1. All right. So this is our marginal revenue function. And if you are given the marginal revenue, to find the total revenue function, giving the marginal revenue to be 50x raised to power 3 plus 4x raised to power 2, for example, and we want to find the total revenue. So how do you apply the calculus to find the total revenue? You will integrate the marginal revenue. You integrate the marginal revenue function to find the total revenue. So in that case, our total revenue will be the integral of 50 all over, this is 3 plus 1, that is 4, x raised to power 3 plus 1, which is 4, plus you add 1 to this, which is 3, that is 4 all over 3, x raised to power 3. Okay? So that is how to find the total revenue. That's how to find the total revenue. So if you are asked to find if you are given the marginal revenue, you will integrate, don't forget, to find the total revenue. If you are given the total revenue, what do? You will differentiate. You find the differentiation of the function to find the marginal revenue. If you are given the total cost, to find the marginal cost, you will differentiate. All right? You differentiate to find the marginal cost function. Okay? So that is a brief application of calculus in business. Calculus in business. So in the part 2 of this video, I'm going to bring a question, then we apply the law. If you love this video, please do share with your friends. Thanks for watching. Bye.